Hi, my name is Bawa John Agmada. I'm doing a presentation on modeling indoor environmental performance of pharmaceutical factory buildings in Nigeria. As a way of introduction, the process of making drugs is a specialized one. It places premium on security, serenity, and control of the built indoor environment. And in achieving this, the quality of the indoor air, the thermal performance, the thermal factors affect indoor environmental performance significantly. Researchers have opined that continual indoor stress reduces physical, mental well-being, performance, and productivity of the workers. A poor indoor environment can also increase absenteeism, respiratory infections, allergies as a result of the biological and chemical contaminants that might be found in the factory. Noting that most pharmaceutical factory buildings are designed without windows, and these production workers are meant to work in this enclosed environment between 7 to 9 hours or 5 to 6 days per week, with only about an hour break daily. There is therefore the need to suggest ways to improve the indoor environmental performance of pharmaceutical factory buildings by proposing a model that will enhance the well-being and productivity of these workers. As a way of literature review, the indoor environmental performance considered condition in the workplace and help in minimizing workers' complaints. Researchers have considered thermal comfort to be dependent on the individual indoor user's adaptation and geographical location, climate, age, and even the gender of the individual. The parameters considered by other researchers to constitute the indoor environmental factors include air temperature, relative humidity, air velocity, while body metabolic rate and clothing insulation are classified as personal factors. Regulatory bodies, both at the international level and the local level, have always regulated the drug production and to a degree the environmental hygiene of these buildings. Indoor air are known to have large amount of impact on the building, which also have direct impact on the inhabitants of the building, far much more than the outer air because of the biological and chemical contaminants. These chemical contaminants include carbon monoxide, carbon dioxide, nitrogen oxide, and a host of others, while the biological contaminants even include the house plants, the pests, and a host of others. Certain researchers have looked at nitrogen oxide to be a source of respiratory problem, while others have looked at low ventilation rate as possible cause. Other researchers have looked at other things such as formaldehyde, and others have looked at cleaning agents as a factor, as the factors. The factors that influence workers' productivity as determined by the indoor environmental performance as related to indoor air quality include air temperature, relative humidity, total voltaic organic compound, and a host of others, while carbon dioxide are mainly as a result of the number of the occupants that occupy a building with little or no air ventilation rate. Over time, formaldehyde has been worked upon to reduce the release of its contaminants because it's been found to cause cancer of the nasal cavity when exposed in remarkably high level of exposure, and symptoms such as irritation that feels like burning of the eyes, the nose, and the sore throat are some symptoms of formaldehyde. Lagos and Ogun State, Nigeria have been chosen because of the higher number of pharmaceutical factory buildings contained in these states. Handheld instruments were used to carry out measures in this research. These are some of the instruments that were used for this research. And as a method of data collection, all the parameters were measured at 15 points in all the production rooms of these 14 pharmaceutical factory buildings. within an interval of 3 to 5 minutes while the machines were running, with occupants in the building and the drugs being produced. And the instruments were placed between 1 to 1.2 meter high for consistency. These pharmaceutical factory buildings were categorized into three based on three factors, which included small, medium, and large pharmaceutical factory buildings, and the number of production workers, the number of drugs, and the size of the production hall were factors that were used to categorize them. And for the purpose of this research, the large pharmaceutical factory building was considered. This is a graph showing or illustrating the total average variation of, for instance, the temperature, which has shown some level of consistency of about 5% average of the 29 degrees centigrade that is allowable in a pharmaceutical factory building. It also shows that air velocity and carbon dioxide were maintained at about 239% and 412% respectively, which are the two indoor air quality variables that were below the 500% threshold. Discriminant and logistic analysis was employed to develop a predictive model for productivity of pharmaceutical factory buildings, and this table shows the canonic discriminant function coefficient. The predictive model here shows that these parameters and the measurements that were derived have to be maintained for a good quality of indoor air and high productivity by workers. So in a large pharmaceutical factory building, these measurements have to be sustained. This shows a logistic regression classification table of both the workers that were productive and those that were not productive. This indicates that without any predictor in the model, the user's productivity will predict about 75% of the group membership. The model in the omnibus test shows that it is less than 0.05, which indicates that the model that has been produced will be a good indicator. Other tests were also carried out to ascertain the workability of the predictive model, and they were found to be excellent. The classification table was also done for both the workers that were found to be productive and the ones that were found not to be productive, and the cut value is 0.500. The overall percentage is 100. This indicates how good the model is in predicting the outcome. The model is developed in the order and the amount of parameters that determine productivity in the pharmaceutical factory building for the analysis carried out with the data collected. It is recommended that in large pharmaceutical factory building, for example, these parameters should be checked regularly to ensure that the developed standard or model be maintained for all the measured parameters to ensure maximal productivity. This study also recommends that research can be conducted for the model for productivity of workers in medium and small pharmaceutical factory building. Thank you for listening. God bless.